Right now, in the middle of the Pacific Ocean, thousands of miles from land, a cluster of thunderstorms is starting to organize into something bigger. Meteorologists are watching two separate areas, one already developing steering winds that could pull it directly toward Hawaii, with impacts potentially arriving in less than a week. At the same time, on the other side of the planet, a tropical wave sitting over Africa right now is about to move off the coast and into the Atlantic, where long-range models are already tracking its possible path. Headlines are calling it terrifying. Some channels are already showing you spinning satellite graphics and asking you to imagine the worst-case scenario. And I get why. Storms make for great thumbnails. But here's the thing. Before you panic, before you assume this is some unprecedented world-ending weather event, we need to actually look at what meteorologists are saying, what the data shows, and what the real historical precedent for a storm like this actually is. Because the difference between a genuinely dangerous storm and a manufactured panic headline usually comes down to about 10 minutes of actual research. And that's exactly what we're going to do today. We're going to break down what's actually developing in the Pacific right now, why Hawaii in particular is such a unique and complicated place for a tropical storm to threaten, what happened the last time a major storm actually did hit the islands, and what the realistic range of outcomes looks like here. No exaggeration, no doomsday framing, just to keep you watching. Just the meteorology, the history, and the numbers as they stand today. Before we get into it, I want to know where you're watching from. If you've ever lived through hurricane season in Hawaii, the Gulf Coast, the Caribbean, anywhere, drop a comment and tell me what it's actually like to watch a forecast cone update day after day, not knowing if it's going to hit you or curve away at the last minute. That waiting is its own kind of stress, and I think it gets lost in a lot of storm coverage. And if you want to stay ahead of every major weather story as it develops, subscribe to the channel. It's completely free, and it genuinely helps us keep making this kind of content. A thumbs up goes a long way too. Let's get this one to 6,000 likes so it reaches more people who actually need accurate information right now instead of panic bait. Okay, let's get into it. As of this week, the National Hurricane Center and the Central Pacific Hurricane Center are watching two separate systems. And it's important to understand they're not the same storm, even though some coverage online is blurring them together. The first is sitting over Africa right now. It's a tropical wave that hasn't even moved off the continent yet, forecast to push out over the Atlantic Ocean in the coming days. Long-range computer models give it a reasonable chance of organizing into at least a tropical depression once it does, but forecasters are deliberately keeping the confidence low, because a system that hasn't even started developing yet is one of the least reliable things in meteorology to forecast with any precision. Most long-range projections currently show it eventually curving north into the open Atlantic, away from land, though that could easily change. The second, and the one generating the most attention, is developing in the eastern and central Pacific, in the general direction of Hawaii. Meteorologists have identified a specific window, roughly the second week of August, as the most likely period for a tropical wave in that region to organize into a real system. If it does develop on schedule, steering winds in the atmosphere could carry it close enough to the islands to bring dangerous surf, heavy rainfall, flash flooding, and potentially damaging wind by the middle of the month. Here's the important nuance that gets lost in alarmist headlines. As of right now, this is not a named storm. It's not even a tropical depression yet. It's an area of disturbed weather that forecasters are watching because the ingredients for development are present. Meteorologists talk in terms of probability for exactly this reason, because at this stage, there's still a wide range of outcomes, from the disturbance fizzling out entirely over open water, to it strengthening into a tropical storm that stays offshore, to a worst-case scenario where it organizes quickly and tracks directly over the islands. What we can say with confidence, because this part isn't speculative, is that this Pacific hurricane season overall has been forecast as an active one for the Central Pacific Basin specifically, with government forecasters putting the odds of an above-average season at around 70%, a notably higher probability than what's being predicted for the Atlantic this year, where a strengthening El Niño pattern is actually working to suppress storm development. That contrast matters, and we'll get into exactly why in a moment. If you've spent any time covering Gulf Coast or East Coast hurricanes, Hawaii operates by a set of rules that surprises a lot of people, and understanding those rules is the key to understanding why this particular threat gets so much attention from meteorologists every single summer. Most of the time, storms that form in the deep tropical Pacific south of Hawaii actually weaken before they get anywhere near the islands. There are a few reasons for this. Ocean water temperatures around Hawaii tend to run cooler than the water further south and west, which rubs approaching storms of fuel. Wind shear, the difference in wind speed and direction at different altitudes, tends to be stronger near the islands, which physically tears storms apart before they can organize or intensify. And the islands themselves are relatively small targets sitting in an enormous ocean, meaning most storms that do stay strong simply pass to the north or south without making a direct hit. This is why, historically, direct hurricane landfalls in Hawaii are genuinely rare compared to the mainland United States. But rare doesn't mean impossible, and it doesn't mean low impact. When a storm does track close enough, the consequences can be severe precisely because the islands are so unprepared for it relative to somewhere like Florida or Louisiana, where hurricane infrastructure and public awareness are baked into daily life for months out of the year. The clearest example remains Hurricane Iniki in September 1992, still the most powerful hurricane on record to strike Hawaii directly. Iniki made landfall on the island of Kauai as a Category 4 storm, with sustained winds around 145 miles per hour. It killed 6 people, destroyed or severely damaged over 1,400 homes, and caused roughly $3 billion in damage, at the time making it the costliest natural disaster in Hawaii's history. What made Iniki so dangerous wasn't just its strength, it was the fact that Kauai's infrastructure, tourism industry, and building codes simply weren't built around the assumption that a major hurricane would ever make a direct hit. Recovery on the island took years. More recently, Hurricane Lane in 2018 offered a different kind of lesson. Lane never made a direct landfall. It passed to the south of the islands as it weakened, but it still dumped catastrophic rainfall, with some areas of the Big Island recording over 50 inches of rain in a matter of days, among the highest tropical cyclone rainfall totals ever recorded in the United States. Widespread flooding, landslides, and road washouts followed, even without the storm's eyewall ever crossing land. Lane is the textbook example of why proximity alone, not just a direct hit, can be enough to cause serious damage in Hawaii. And then there's the more recent, harder lesson. In August 2023, it wasn't even a hurricane that caused Hawaii's deadliest disaster in modern history. Hurricane Dora passed several hundred miles south of the islands, never coming close to landfall, but the storm's outer wind field combined with dry conditions and existing weather patterns to fan devastating wildfires on Maui, particularly around the historic town of Lahaina. That disaster killed over 100 people and became one of the deadliest wildfires in modern American history, a stark reminder that in Hawaii, a storm doesn't need to make landfall at all to become genuinely catastrophic. This is the pattern meteorologists are watching for every single time a system develops anywhere near the islands. It's rarely a simple question of will it make direct landfall or not. It's a much broader set of questions about rainfall, surf, wind field size, and secondary hazards like flooding and fire risk, all of which can cause serious harm from a storm that technically never comes ashore. Our Pacific season is expected to run hotter than the Atlantic season. You need to understand a climate pattern that shows up constantly in seasonal hurricane forecasting, El Niño and La Niña, together known as the El Niño Southern Oscillation, or ENSO. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia and allowing cooler water to rise up along the coast of the Americas. During an El Niño pattern, those trade winds weaken, and warm water that would normally be pushed west instead pools and spreads across the central and eastern Pacific. During a La Niña pattern, the opposite happens. The trade winds strengthen, and that warm water gets pushed even further west than usual, while cold water rises more aggressively along the Americas. This matters enormously for hurricane formation because these patterns change wind shear across entire ocean basins simultaneously. In the Atlantic, El Niño, conditions tend to increase wind shear across the Caribbean and tropical Atlantic, which tears apart developing storms before they can strengthen, generally suppressing hurricane activity there. But in the central and eastern Pacific, that exact same El Niño pattern tends to do the opposite, reducing wind shear and warming the very waters that storms need to form and intensify, generally boosting activity in that basin. This is exactly the setup meteorologists are describing for this year. A developing El Niño pattern, in some forecasts described as an unusually strong one, is expected to significantly suppress Atlantic hurricane activity, with government forecasters revising their named storm predictions downward multiple times over the summer and now putting the odds of a below normal Atlantic season at around 75%. Meanwhile, that same El Niño signal is a major reason the Central Pacific Basin around Hawaii carries a 70% probability of an above-average season this year, with forecasters projecting as many as 13 named storms or tropical depressions in that basin alone, well above the typical average of 4 or 5. So when you see headlines about a huge storm threatening Hawaii this month, this is genuinely not random bad luck. It's consistent with a climate pattern that forecasters flagged as likely months in advance, and it's exactly the kind of season Hawaii's emergency management agencies have been telling residents to prepare for since the seasonal outlook was first published. One thing that separates responsible storm coverage from panic content is understanding how forecasters actually communicate uncertainty, because it's genuinely more sophisticated than a lot of viral weather content gives it credit for. When a system like this is first flagged, forecasters assign it a development probability, essentially a percentage chance, that it organizes into a tropical depression or storm within a given window, typically 48 hours and 7 days. These percentages get updated multiple times a day as new satellite data, atmospheric model runs, and reconnaissance data come in. A system sitting at low or medium development chances, the way this one currently is, means real. Uncertainty still exists. Not that forecasters are hiding a certainty from the public. Once a system does organize into a named storm, the National Hurricane Center and Central Pacific Hurricane Center generate what's called a forecast cone, the familiar cone-shaped graphic showing a storm's probable track over the following 5 days. It's worth understanding what that cone actually represents, because it's widely misread. The cone doesn't show the size of the storm or the area that will experience impacts. It shows the probable path of the storm's center, based on historical forecast error, meaning there's roughly a 2/3 chance the storm's actual center stays within that cone. Impacts like heavy rain, dangerous surf, and tropical storm force winds routinely extend well outside the cone's boundaries, sometimes by well over 100 miles, which is exactly what happened with Hurricane Lane's catastrophic rainfall in 2018, even as the storm's center stayed offshore. This year, forecasters have actually made a significant change to how this information gets communicated specifically because of past confusion. Starting this season, the official forecast cone now incorporates inland tropical storm and hurricane watches and warnings directly onto the graphic for Hawaii, along with the continental U.S., Puerto Rico, and the Virgin Islands. The goal is to stop people who live away from the immediate coastline from assuming they're automatically safe just because they're not directly in the cone's path. Hawaii has also gained new storm surge alert products this year, specifically designed to give coastal communities probability-based forecasts of water levels within 72 hours of a storm's potential impact, since storm surge, not just wind, is one of the most dangerous and least understood hazards tied to any tropical system. This is worth sitting with for a second because it's the opposite of a panic narrative. This is what responsible, evidence-based disaster communication actually looks like. Forecasters using improved tools specifically to reduce public confusion and prevent people from underestimating a storm's real reach. Here's the honest answer, and it's not the answer that makes for the most dramatic thumbnail. Right now, today, this is a developing situation worth watching closely, not a confirmed catastrophe. The system threatening Hawaii hasn't even organized into a tropical depression yet at the time this is being written. There's a real, forecaster-identified chance it strengthens and tracks close enough to bring serious impacts to the islands in the coming week. There's also a real chance it stays weak, passes well offshore, or breaks apart entirely under wind shear, the same fate that quietly ends the large majority of tropical disturbances that form every single hurricane season without ever making headlines. What makes this genuinely worth paying attention to isn't any single storm, it's the broader pattern behind it. Hawaii is sitting in a Central Pacific season that forecasters correctly predicted would run hotter than normal months in advance, based on measurable ocean and atmospheric conditions, not guesswork. That's a real data-backed reason for residents and visitors in the islands to take preparation seriously this particular season, separate entirely from whether this specific system develops into something dangerous or fizzles out over open water. And this connects to something we keep coming back to in every disaster story worth telling, honestly. The headline, "Huge Storm is Coming," and the headline, "An above-average season," was forecast months in advance, and a system is now being watched closely, as it should be, describe the exact same underlying reality. One version is designed to generate panic and clicks. The other is designed to give you something you can actually act on. We'd rather give you the second one, even if it doesn't autoplay as well. If you live in Hawaii, or you have a trip planned there in the coming weeks, here's what's actually useful, separate from any single storm's specific track. Know that Hawaii's hurricane season runs officially from June through November. But the statistical peak, the period when the vast majority of close calls and direct impacts have historically occurred, falls in August and September specifically, driven by the warmest sea surface temperatures of the year. If you're going to take any single piece of seasonal timing seriously, it's that this exact window right now is historically the most dangerous stretch of the entire season for the islands. Have a plan that accounts for more than just wind. As Hurricane Lane and Hurricane Dora both demonstrated in very different ways, a storm doesn't need to make direct landfall to cause the most severe damage of the entire event, whether through catastrophic rainfall and flash flooding, or through fire risk driven by a storm's outer wind field combined with dry vegetation. Know your evacuation zone if you're in a coastal or flood-prone area. Know your nearest shelter if you're inland, and don't assume you're safe from serious impact just because a forecast track shows the storm's center staying offshore. Pay attention to official Central Pacific Hurricane Center updates rather than viral social media graphics once a system does organize, since official forecasts are updated multiple times daily with the latest model data, while a screenshot circulating online could already be many hours out of date by the time you see it. And build a basic emergency kit before a storm is actually approaching, not during the scramble beforehand. Water, non-perishable food, flashlights, a battery-powered radio, and enough supplies to be self-sufficient for at least a week, since a direct impact to the islands could disrupt shipping and supply chains for longer than a mainland disaster. Might, given Hawaii's dependence on ocean and air freight for a large share of its goods. None of this requires panic. It requires the same unglamorous, boring preparation we talk about in every one of these videos, because it's genuinely the thing that determines outcomes far more than the storm's peak wind speed ever does. Here's what's actually worth taking away from this story. A tropical system developing near Hawaii this month isn't some unprecedented anomaly, and it isn't proof that the world's weather has suddenly turned against us. It's a fairly predictable consequence of a climate pattern that forecasters flagged months in advance, showing up more or less exactly on the timeline they said it would, in the basin they said would be most active this year. The Atlantic, meanwhile, is having a quiet season for the exact same underlying reason, which is a detail that rarely makes it into a scary thumbnail, because expected seasonal pattern unfolds roughly as predicted, doesn't generate the same panic clicks as huge storm incoming. That doesn't mean the threat isn't real. It absolutely is, and Hawaii's history, from Iniki to Lane to the wildfires tied to Dora, proves that even storms that never make direct landfall can produce genuinely severe, sometimes deadly consequences. But the responsible way to hold that reality is the same way we've approached every disaster story on this channel. Understand the actual science. Understand what forecasters are and aren't saying. Prepare based on real risk rather than manufactured panic. And keep watching the updates as they come, because a system sitting at low to medium, development odds today can look completely different within 48 hours in either direction. We'll be tracking the system closely over the coming days, along with the Atlantic disturbance moving off Africa, and we'll update you the moment either one organizes into something more defined. Subscribe so you don't miss any of it, and drop a comment, letting me know if you're in Hawaii right now or watching this system from anywhere else in the Pacific. Let's get this one to 6,000 likes so it reaches people who need real information instead of another panic headline. Stay safe, stay prepared, and we'll see you in the next one.